So hopefully this is the last video. It's probably going to be the entire 15 minutes long, and I may end up having to do another really short one right behind this one, but we'll see. Okay, so in this video we are going to talk about the process of translation, so how the mRNA is converted into proteins. It's its own section because it's a little bit more of a newer concept than transcription, because transcription is really just a lot like replication, but translation is just a little bit more involved, so it's its own little section. Okay, so translation, again, it occurs on the ribosomes out in the cytoplasm. The ribosome has two subunits that have 4 binding sites total. The small subunit, which is this part right here, okay, the small subunit is going to hold the mRNA, which is shown in purple. It's going to hold that mRNA, again, with the nucleotides facing up, because essentially those nucleotides have to face up into the large subunit, which is this part right here, the large subunit. Again, if the nucleotides were to be facing down, they would be stuck in the small ribosomal subunit, and they would not be able to be read by the large subunit. So one way to think of the ribosome is kind of like a hand pulling a string through it. So your like 4 fingers are the small subunit, and then your thumb could be like the large subunit, I guess. I don't know, it's not the best comparison, but it's like the ribosome holds the mRNA like your hand, and then the string would be the mRNA that you're like pulling through your hand. So the large subunit has 3 sites, 3 binding sites. It has the A site. The A site is the landing site, so to speak. So that is where tRNAs are going to come into the ribosome with the codon and anticodon pairing. So if we look here, let me erase some of this picture here that I have going on. So if this is my tRNA, right, here's my amino acid. And then this part right here is the anticodon, which is AAG, which is going to be the complement to UUC right here on the mRNA. And so that tRNA is going to enter into the A site, where the mRNA codon will match up with the tRNA anticodon. Okay, the next site is the P site. The P site is where the peptide, which is the fancy name for protein, that's where the peptide is going to be elongated. So what we have not shown is that the methionine has already been added. Here's a peptide bond, and then here's tryptophan right behind it. And then the next one that's going to be added is the phenylalanine, which is this guy up here. So this guy is going to come in. It will enter into the A site first, and then from there, the ribosome will essentially pull it through until it ends up in the P site. Once it's in the P site, it's going to let go of its phenylalanine amino acid, which is going to be added to the growing peptide chain right here, the growing protein. And then the E site is where the now empty tRNA is going to go to leave the ribosome. So if you look here, this guy is empty. He was originally carrying, oh, look at all these dots I'm making. He was originally carrying methionine, and I know that he was originally carrying the methionine because this guy right here is the complement to my start codon AUG. So he was once carrying methionine. This guy right here was once carrying tryptophan. And this guy again is carrying phenylalanine. Okay, so A site is where the tRNA is going to bring in the next amino acid. The P site is where that amino acid is going to be let go so that it can be added to the growing protein or the polypeptide chain that is being made. and the E site is where the tRNA that is now empty of its amino acid is going to go to leave. It's going to go float around in the cytoplasm and pick up another methionine. This one's going to go pick up another tryptophan, and this one will go pick up another phenylalanine. And they'll just hang out and wait until they are called back. Okay, so translation is going to have the same 3 steps as transcription. It's going to have an initiation phase, it's going to have an elongation phase, and it's going to have a termination phase. But there's a little bit more involved for each of these steps than it was for transcription. So for the initiation step of translation, the mRNA is going to travel by way of the endoplasmic reticulum, and it's going to set itself on the small subunit of the ribosome with the nucleotide sticking up. And then the tRNA that carries methionine is going to come and match up with the anticodon on the mRNA. And then the large subunit will then come in and set itself down on top of that first tRNA, putting its P site on top of the first tRNA carrying methionine. And that whole thing together is called the initiation complex. So if we go back to this picture, the first step in initiation is going to be the mRNA binding to the small subunit. And then the next thing that's going to happen is this guy that was once carrying methionine is going to come in and complementary base pair with the mRNA. And then once that happens, once that start tRNA, that methionine tRNA does that, then that's going to signal to the large subunit of the ribosome to come down and put its P site on top of that methionine. So here this is showing kind of 3 steps later. So this picture is more showing the process of elongation than it is showing you the process of translation initiation. I tried to find a picture. It was really hard to find one of just initiation, but I think I found one in one of the next coming slides. That should be able to help you. Okay. So again, if you need to pause, if you need to rewind and listen again, please do that before you Skype me. I don't mind answering Skypes, but it's really hard to answer 106 Skypes. So if you and some of your friends can't figure it out on a group Skype call, then y'all Skype me. But let's try to make this as smooth as possible. Okay, so the elongation step of translation is when the tRNA whose anticodon matches up with the codon in the A site, it's going to bring its amino acid in, it's going to land there. A peptide bond is going to form between the 2 amino acids, the one that was already there and then the new one that just came in. And then the tRNA that was in the P site is going to move to the E site or the exit site, but it's going to leave its amino acid bonded with all the other amino acids. And then the tRNA in the A site will then move to the P site, and then the next one will come into the A site, and so on and so forth. So this whole process just keeps happening over and over and over and over again. So you come in, right? You are going to move to this site. You're going to drop off your amino acid to the growing chain. Once the tRNA is empty, it's going to go here, and then it's going to leave. The mRNA is going to be pulled through, and then another tRNA is going to come in. Same thing, over and over and over and over again. That's elongation. A site, P site, E site. A site, P site, E site. A site, P site, E site. Or as I like to call it, APE. So it occurs in APE. I don't know why, but that helps you remember it. Okay. And then the last step is termination. So basically when a stop codon is reached, a release factor, which is going to be a protein, it's going to stick itself into the A site. And when that release factor protein is in the A site, the proteins are going to leave, the one that just got made. It's going to leave to go do whatever its job was. So if it was insulin, it's going to leave to go help with blood sugar. If it's hemoglobin, it's going to help pick up oxygen in the bloodstream. Just whatever that protein is, it's going to leave to do its job. And then the two subunits of the ribosome are going to come apart, and then the mRNA is going to be sent back to the nucleus to be broken down. Okay, so here's kind of the whole process of translation. I tried to find the initiation step, really, but it was really hard to find. But here you have the small subunit of the ribosome, you have the mRNA binding to it, you have the tRNA binding to the anticodon-codon pair is binding up, and then at that point the large subunit of the ribosome comes in. It puts its P site down on the tRNA that was carrying the methionine, and then the next amino acid in line goes into the A site, and then from there the methionine and the phenylalanine in this case are bonded together. The tRNA that was carrying the methionine is now in the exit site. It's getting ready to leave. The phenylalanine here is being added, and then the next tRNA with the next amino acid is coming in. So this is showing you the initiation complex here. That's the initiation complex. And then this right here is showing you the process of elongation. Okay, so the overall process for protein synthesis, right? Central dogma theory. So you have your DNA. Here is the promoter that I was talking about earlier, that specific sequence of DNA that the RNA polymerase is going to recognize. Okay, so the entire thing is going to be transcribed into pre-mRNA, right? It has to get its 5' cap and its poly A tail and all of its introns cut out before it can be considered mature, ready to leave the nucleus, ready to leave the house, mRNA. And then once it does that, we can then go through translation so that mRNA can be converted into proteins, sometimes called polypeptides. So peptide is another name for protein, poly is many, so there you go. Okay, and then the last thing that I wanted to talk about, and yay, this video is going to be less than 15, well, it's going to be exactly 15 minutes, but there won't be another one. So here is the codon chart that you use that I did the screencast about the other day. I just wanted to make a couple comments about it. The codons are considered, or the amino acids, this whole chart is considered, or the genetic code is considered redundant but unambiguous. So what does that mean? Redundant meaning that there are multiple codons that can code for the same amino acid. So for example, all of these guys over here code for arginine, these code for arginine, all of these code for leucine, all of these are going to code for tyrosine, these are going to code for threonine, these are going to code for proline, these are going to code for serine. So you can see that there are multiple different codons that code for the exact same amino acid. So that's the redundant part, but it's unambiguous. So for example, CUU, always and forever, is going to code for leucine. It is never, ever, 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 ever going to code for any other amino acid other than leucine. However, CUC, CUA, and CUG all code for leucine. So it's redundant, but it is unambiguous. So yeah, let me know if you have any questions about anything. And again, go do some jumping jacks or some push-ups or something to get your blood flowing, because it will make all of this information stick in your head better. Until next time.